So today we're going to talk about how to connect a Wi-Fi enabled Arduino board to an iOS device. And we're going to start off by just having a quick look at the hardware. In this case, I have a photoresistor and a speaker connected to a clone Arduino board which we make called the Oak. And this is the daughter card that you can connect right into the Oak through this header here, and this is what we codename the Maple, but in actuality it's a 802.11bgn rated Wi-Fi device. So we connect that up right here, and finally this is what's feeding it power right now. You could optionally connect it to a battery through here, but I just have it feeding USB power through our USB connector right over here, which we call the Olive. And these wires connected to here, this is the photoresistor connected to analog 0, and this is the speaker connected to analog 2. So the speaker, of course, has the ground and the wire that's going to analog 2, and the photoresistor has the ground, power, and the sensor wire connected to analog 0 right there. So what we want to do is we want to feed the sensor information into the iOS device so the iOS device could see how much light is hitting the photoresistor, and that will display on the iOS device. And the speaker is so you could generate a tone from the iOS device. So basically on your iPhone there's a button that will, when you hit it, it'll generate a tone, and on the actual iPhone itself you should see numbers that change according to how much light is hitting the device. So the way that we have it connected to the iPhone is we have a direct connection, so it's called an ad hoc connection. Rather than using a network and going through a router and all that kind of hassle, I'm going to show you how to connect this Arduino Wi-Fi device directly to an iPhone with no intermediate kind of router or anything like that. So it's going to be a direct connection. And if you want to see it in action now, I have it on the simulator, and as you can see here, we've got the photoresistor value changing, and when you hit the remote tone right there, you'll hear that the Arduino generates just a regular tone. Of course, you can take this idea and you can expand upon it. You can have a robotic arm that creates certain actions or movements. You can control servos. You can control a motor. You could get feedback from a motion-sensitive device, a ping device, ultrasound device, a radar device like we had in our other demos. But in this case, I wanted to keep it really simple, just to show you the bare bones of what you would need to do in order to gain input and also to send in output out of the Arduino. This concludes the external part. I'm now going to move into the computer to show you how everything's set up. So this is a simulator showing what the application is doing on the actual iPhone. You can see that the photoresistor value is changing just a little bit. It's actually reading from the device. If I cup my hand over the photoresistor, you'll see that it jumps up, and it should jump past 1,000 if I cover it really well. So basically what's happening is the photoresistor is sending a value out to the Wi-Fi device. The simulator is connected to the Wi-Fi device directly through an ad hoc connection, and it's inputting the value into the UI label on the actual simulator. And if we hit the Make a Remote Tone button, you should hear that. That's a tone from the speaker that's connected to the Arduino. Nothing fancy there. I just thought I'd show a way that you could go both in and out. So you might be wondering about actual hardware that's used for doing this. On the website, you'll see that you can purchase the Wi-Fi board right here, and it uses the microchip Wi-Fi breakout right here, and that supports 802.11b, G, and N. All the information is right on our website. If you go to the website, you'll see that all of the documentations and specifications and everything are right inside. So if you want to find out more about that particular chipset, very simple to do so. Or if you want to create your own board, you could use our schematic and make it yourself if you wish to. We are using the oak as well, which is has this breakout specifically for the Wi-Fi board that breaks out right into it. And finally, for communications, we're using the olive, which is right up here. And that's what we use to program the Arduino clone that we made. So once you've got the hardware and you've got it all assembled, just like in the previous live video, you pretty much just have to join the headers together and connect it to the USB port on your computer. Then what you would need to do is download the library for using the Wi-Fi board. And we chose to go with Async Labs open source WeShield library. And you can see that right here. It's at github.com asynclabs/WeShield. And I'll also put this link in the description area for this video so you can get at it easily. But it uses this particular library with no modifications. So if you load this into your Arduino software, you should be able to use it right out of the box. And when I show you the source code that we use to create the program, you'll see it's really pretty simple. It's just a few lines of code. So once you've got this library, put it inside. It should be on my computer, it's in the Documents folder. And inside the Arduino folder, in your Documents folder, you'll find a place that you just drop the library right in there. And once you do that, you should see that you have the option to include it inside of your program. So right here, all we have to do is we're just setting the actual SSID right here, and you could set that to almost anything really. I set it to Weburban Wi-Fi, and right up here, what I like to do is I made the local IP and gateway IP the same, because what we're doing is we're doing an ad hoc connection. And what that basically means is that the computer that you're connecting to, there is no router in between. So your gateway is basically the Arduino. So the Arduino is both the machine that you're hitting for communications and also the gateway that you're hitting. So these two numbers can be the same. And I chose 192.168.1.1. This is a typical internal IP number. If you don't know anything about internal IPs, just use this number. Otherwise, you can use any other internal IP style number. I didn't choose to put any kind of security in, though you could choose to secure it. I would say that in your first attempt, I would bypass security and just do an open connection. Security type equals 0 right there. But in the future, if you want to secure it, you could do WEP or WPA. So we're skipping these two since we're not doing any kind of security. Now this is really important. For wireless mode, you need to put down in here that it's wireless mode ad hoc. Reason being is that, like I said before, you're doing a direct connection. You're not using any kind of gateway. You're not using any kind of router in between. So down here you want to choose wireless mode ad hoc. Finally, this is the chunk of what's going on down here. So let's talk about this particular block here. So right over here we see that we have a setup and a loop. Setup being a initialization of the WeServer send my page, and down here WeServer server task. You could safely just leave these alone and come up here and focus on the send my page function right here. So what this does is it consumes the URL and it spits something out depending on what the URL is passed to it. So here we have a plist that we're making dynamically. And if you know anything about iOS programming, you'll know that plists are extremely easy to incorporate into your application. We're going to see that when we do the objective-C section. But in this particular part, we're creating a plist for the photoresistor with an integer value of the sensor value. So right here is just a really simple Arduino 101 kind of assignment of analog 0 to the integer value for sensor value. So sensor value is now being assigned whatever comes out of analog 0. And here you're just replacing that particular value inside of the print chain. So what we're doing is we're just printing out a text block that's going to be output, and I'll show you an example of that in a minute. And whenever you ask for sensors.plist, it's going to spit this out. Now if we go to the next thing, we'll see that we have tone. So whenever tone is requested from the wireless board, it's going to generate just a simple tone. And here we have tone, analog 2, this is the frequency of 800, I think it's kilohertz, and then this is going on for 1000 milliseconds, which is about 1 second. So we have a tone that's generated for a second out of analog 2, and the speaker is connected to ground in analog 2, and then here we're just printing out tone yes. So this can actually be blank, you don't even have to put anything there, but if you want to have some kind of return value to check for, you can put something in there. And finally, this is what came with the actual library, is just a simple example of when you don't put anything in there, it just spits out hello world. So we're not actually using this in our objective-C, but I kept it in there because this is what comes with the example program. So now that we have this, you upload that to your Arduino, and once you upload that to Arduino, you need to configure your computer to connect with the Arduino device. Because remember, you're not connecting to your router anymore. You're connecting directly to the device. So you need to configure your computer, and I'll show you how to do that too. So here we just go into, now I have both an Ethernet and an airport connection. So I have a Wi-Fi connection to the Arduino, and I also have an Ethernet connection to the internet. We're going to look at the wireless connection because that's how we're connected to the Wi-Fi. And as you can see here, I have Weburban Wi-Fi, which we input into our Arduino application as the active Wi-Fi connection. Okay, so once you've found whatever you named it, and once you go to and set and have it and connect and join that network, then what you need to do is you need to fill in the actual IP address. So what you're going to do is you're going to give yourself a IP address. So remember we gave the Arduino 192.168.1.1. Well, here we're going to give ourselves 192.168.1.2. And so once you've done that, you've assigned yourself an IP address, you've got the device with an IP address, and we're ready to rock and roll. Okay? So once you've connected to your device, you can now test it. And one way that we can test it is we can bring a browser up, and if you put in 192.168.1.1, which remember is both the gateway and the IP address for the Arduino, we can then put in sensors.plist and get our plist that we're going to use in our objC application. What would happen if I put tone in here? What do you guys think would happen? I get the tone. So there, I was able to generate that tone. Now what would happen if I didn't put anything in here? I would get hello world. So you can see that our Arduino is already working. So it's working with just a regular browser because I have that Wi-Fi connection. Okay? So we're pretty much like 80% done at this point because we've got the Arduino, and that's broadcasting an SSID that we're connected to, and then we have the IP address and gateway configured, and the Arduino application compiled properly, and it's outputting plist information if we put in our sensors plist. So all we need to do, and this number, by the way, if I refresh it, you'll see that it changes because it reflects the actual value coming out of the Arduino's photoresistor. See that? So the next thing we need to do is we just simply need to create our objC application. So right here is where most of the action happens. Now, I'm assuming you guys know how to create iPhone applications, so I'm not going to go over how to create an iPhone application, but just in a real nutshell, I just created one text field right here that has a varying number that I created an IB outlet for, and then this is just a simple button that goes to a method inside of my main delegate. And all I do is, right here, I'll show you what I'm doing. In my viewDidLoad, I make a NS timer that reschedules every 2 seconds to query plist. And then my query plist is simply an NS URL pointing to a string that goes to 192.168.1.1/sensors.plist. And a dictionary is just a dictionary with contents of URL. You can see that it's really simple to consume that plist and convert it to a dictionary. Once I have it as a dictionary, I can then get the object for key and get the string value for that and stick it right in photoresistor value.txt, which is that UI label. So you can see just how simple it is. I mean, it's really basically 3 lines of code. This is just an NS log to show me that the value is updating when I was creating the app. Now, how do I make that tone? Remember how we had that button that created the tone? Well, all I'm doing is, in make tone, it's even less. It's 2 lines of code, because all I'm doing is putting the URL to tone right here, and then basically creating a dictionary of the output, which then brings the website up and triggers it within the Arduino. So once we compile that, we then have this final product, which is the iPhone application remotely connected to an Arduino via Wi-Fi. And I just wanted you guys to see just how simple it is and I'm sure this could be translated very easily to other platforms as well. Even really simple platforms like the BlackBerry Curve, I'm sure would very easily be able to do something like this if it has Wi-Fi. So if you have any questions, please don't hesitate to give me a buzz. These boards are now available at store.weburban.com, and hopefully I'll be seeing your project soon. Thank you.